All right, group, this is the exam review for semester 1, unit 5, piecewise defined linear functions. We're going to work through each problem here. All right, let's start with number 1. Here we have our system, our piecewise system, f of x, and we have two parts to our system. We have the 2x here that has a domain from -1 to 3. So that function is only when x is -1 to when x is 3, and then we have the -x minus 4 when your function is from 3 to 6, not including 3 because we don't have an equal to bar on that less than symbol. So if we look at part A here, f of 5, we want to figure out where does 5 fall? Is 5 between -1 and 3, or is 5 between 3 and 6? Well, we know 5 falls between 3 and 6. So we're going to use the -x minus 4 function. So wherever we have x, we're plugging in 5 because we're doing f of 5. -5 minus 4 would be -9. So that's your final answer for f of 5. So then f of 3, we have to figure out where does 3 fall. Is 3 between -1 and 3, or is it between 3 and 6? This is a special case. So we need to look at our two parts here. The top domain is x less than or equal to 3. So 3 definitely falls in there because it's equal to 3. Down here, this is not equal to 3. X cannot be 3 in that case. So we're going to use the first function here. So it'll be 2 times 3, which is 6. For part C, f of -1, we want to find where x is -1. If we look at that top domain, x is -1 to 3, and it's including -1. So we're going to plug it into our first function. So we end up with -2. Part D, we have 6. 6 is definitely in that second domain because it's going from 3 to 6. X is including 6 there. So it'll be -6 minus 4. We get -10. All right, f of 2. So 2 is 2 between -1 and 3. Or 3 and 6. It's between -1 and 3, so we're going to use our first function here. Plug in 2 for x, and we get 4. So on those problems, anywhere, whatever you're plugging in is going to be your x in each problem. Here, now we have the system, and we are going to graph it using our table. We're going to fill in our table first, and then we will graph it. So we're going to take it one function at a time. What I like to do on my tables is I split it so that I know that my two functions are separate. Okay, this is going to be my 2x function over here, and this is going to be my -x minus 4 function here. We're going to fill in our table first. We get our x values from the domain. So for our x values here, the 2x function is -1 and 3. The way that we get the y values is by plugging those in. So since this is 2x, we're going to plug in our x value for the x in our function. So we get out a y value of -2. So that point is -1, -2. Then we go to 3. We're going to plug 3 in for x. 2 times 3, we get 6. So that point is 3, 6. Now, there's one special thing we have to do when we graph, and it's doing an open or closed point. So if we look up at our domain, okay, both of these are equal to on the less than symbol, meaning both of these are going to be closed circles. So we can go ahead and graph those. We'll graph -1, -2, and it's a closed circle. And then we'll graph 3, 6, and that's also a closed circle. And we connect those dots. So we're done with the first part of our piecewise. The second part, we have to do the same as the first, but we're talking about a different function now. We're talking about our -x minus 4. So our x values for that are 3 and 6. And again, we get those up here from the domain. So we're going to plug in 3 for our x, and we get out -7 there. That point is 3, -7. And then we plug in 6 for x in our second one. So we get out the point 6, -10. So again, we have to find what type of points we have. So if we look up here in our domain, the 3 is associated with just a less than symbol. So that's going to be an open circle. The 6 has an equal to on it, so that is going to be a closed circle. So when we graph these, if we go 3, -7, we put an open circle there. 6, -10 will be a closed circle. And we can connect those dots. And that's graphing a piecewise function. Okay, the next one here is picking out a y value when you're given an x value on a graph. So we did this in the first one, but now we have a graph instead of a written algebraic function. So if we look, our first one here in A is g of -2. So if we go over to -2 and up, that crosses when y is 4. So g of -2 is 4. G of 3, we go x is 3, up where it crosses on the graph here is at y equals 3. So your answer there is 3. When x is 3, y is 3. Now we have 1. So we go to when x is 1, y is also 3. And then when x is -1, y is 2. Go up to 2 there. And our last one here is when x is 0. So this is a special case. We have 2 points, okay, when x is 0. We always choose the point that is closed. So in this case, we do not want the point that is at the origin. We want the point that's up here at 3. So g of 0 would be 3. Some of the questions that we get on these is, what if there's 2 open circles? You know, what if we had an open circle here instead of closed? In that case, we say that the limit does, or the point does not exist. So if that happens where you have 2 open circles, we just put D and E does not exist for that value. Okay, now here we're going to write an equation. So now we're writing our piecewise system here based on a graph. So we have the same graph we just worked with. We're going to pick out the equations. And the way we do that is we're going to start with our left portion. And we're going to find the slope. And we're going to find the y-intercept of that line. So if we look at our slope, I would say if we can pick out this point here, we go up 2 and over 1. So our slope is 2 over 1. Because that line is going down, it's going to be negative. Okay? And you do not have to write the 1 here. Okay? So you've seen how I wrote the 1. You can just write -2. Ooh, I put that in the wrong spot. -2 for this one. Your y-intercept is b, okay? And as you can see, that crosses at 0, 0, so your b value will be 0. And we put this in the form y equals mx plus b. So y equals -2x plus 0. In this case, you do not have to have the plus 0. You can take that out. If you put it in, it would not be incorrect, but you don't have to write that. So down here, our first function is -2x. Remember, you don't have to write the y on the inside. G of x is kind of like your y in this case. So you can just write the part on the other side of the equal sign. For the domain, our domain starts here, okay, and then it goes infinitely to the left-hand side. So if it starts at 0, okay, and it goes to the left, we're talking about all numbers less than 0. So it would be x is less than 0. You do not need an equal to symbol on that because it's an open circle at 0. So again, it's open if you have that equal to symbol. If it's closed, you can put the dash there, but we don't need it on this in this case. We will need it on our next one. If you look at the next line, we'll jump to the right portion. Fill in our domain here. Okay, on the right portion, we have a horizontal line, and we talked about horizontal lines a little bit this year, but we can go ahead and find the slope and the y-intercept. That's not a problem, and we can write it like normal, y equals mx plus b, but we'll figure out what's going to happen here. Our slope of a flat line is 0. Okay, we're not going up or down anyway, it's just 0. Our y-intercept, we can see it crosses at 3 on the y-axis, so our b is 3. So if we fill in our y equals mx plus b, we get y equals 0x plus 3. What happens is that 0x cancels out, so our line is just y equals 3. So our second equation is just, you can just put 3 in the box there. For the domain, we look at x values. So our x value to start is 0. Okay, and it goes to 4. Both of those will get that equal to line on the bottom because they are closed circles. And that's all there is for graphing, taking or writing the equations from a graph.